observations here, okay, about stuff that's going on. Okay, so let's make a wave there, Ivan. Just, all right, hold on. That's multiple waves. Just one wave, please. For our, do it again.
Keep this slower.
Keep going. All right, one more wave. Talk to me, class. What's going on with the wave here with the rope? You can keep going, well, so we can kind of watch. What's going on with the rope? It is moving.
It's not going anywhere. It's like going up and back down.
It's going up and down. Maybe we can tie a. Hold on there, Ivan.
What are you tying on?
I'm tying on a Kleenex here. All right, make a prediction. What is going to happen to that Kleenex?
It's going to go up and down.
It's going to go up and down. It's not going to move that way, but you said in waves. Well, okay. Do it again there. So that, all right. Now you can think of that as representing one particular position on the rope. Okay. Let's swap out here, Kevin. Can you get that sort of motion that you had going on earlier?
With that?
Yeah, with that. When we were practicing before class. So. Okay, so it's really just going up and down. Do y'all see that?
Mm-hmm.
So one of the things about waves is a wave does not move the matter. Okay. Does anybody remember from your readings how would you describe a wave if it's not moving the matter? What's that?
Transverse.
Transverse, that's a type of wave, okay? Well, I mean, is it moving this? Is it moving that? Okay, it's moving it, and it's moving it, yeah, sure. It's moving it up and down, but, no, we'll do a longitudinal wave in a second. This is a transverse wave, because here's what's going on. The wave is moving. We want to see that wave move. Maybe bring it a little bit closer there, Kevin. There we go. Look at the wave. Do you see the wave moving?
Very excited.
I see the wave moving, but this piece right here is not moving. So the question is, what is a wave?
Playing over their intercom. So can you work to get that turned off?
Mr. Town, did you get that?
I don't remember reading it, and I can't remember what it said.
Right.
Well, I like a change to the medium.
A change in the medium? Okay, that's true, because the medium here would be the rope. So we can see that something is moving along here, right? Well, yeah, it's moving just a little bit. But overall, yeah, there's an energy transfer along here, okay? And we can see that energy is moving here to here to here to here to here, but the rope itself is not moving, okay? Out in the same way. All right, I want y'all to get that spring, see if y'all can make a longitudinal wave. Hold it in there. Hey, Mr. Bradbury.
Look, this is the egg bot.
Awesome.
You probably need time to fix up and
I
get
thought
the
we were
plastic
getting
things up
cookies.
marked, and you can also use
That was nice.
Oh, I love that.
All right.
You tried on golf balls?
I haven't yet,
Okay, I'm thinking the students are not sure we'll try with golf balls.
but she's all yours. It's all the same principles that it is on my leg.
I love it.
Bless you.
Thank you very much.
You're welcome.
And then did you go when you push your
Hand to another person. You get on the ground and
That
you're
one
gonna
was
go
that
like
one was
this on the
practically
ground.
because
Go,
he was
go.
moving it up and down. He wasn't there pushing or pulling.
Laura, you're gonna put somebody else here. Kevin, you stay with
Yeah,
this
you
one.
can't do two things, Kevin. Come on.
No, Emily, you're on the slinky.
I'm on the
Emily.
slinky. Okay, what
Slinky
am I doing?
detail. So, see if you can make a longitudinal wave.
You push or pull.
Say, put it on the ground there. It'll probably be a little bit easier there for us. All right. Well, I hate to break it to you. That is still a transverse wave.
Just push or pull it.
Okay? There you go. Right.
You can see it moving through it.
Okay, but we can see it moving through that with the rope there.
But yeah, it looks like there's an object going like back and forth. Is what it looks like.
That's true. I'm gonna have to get another tissue.
very mesmerizing.
You're judging his materials.
I am. I'm truly judging his materials. He clearly did not plan ahead on materials. I'm judging.
Y'all are playing catch? That's so nice.
You're catching waves.
He said that. Emily. Oh my gosh, that was so.
All right. Now let's get that. Okay.
Wait, and that one is moving.
Okay. So with your fingers, point the direction of the wave. We're going to say that Emily is starting the wave. Point the direction of the wave. Everybody point this way. Okay? All right, the wave's moving that way. Actually, we can do. Now, with your other hand, point the direction that the Kleenex is moving back and forth. Yeah, look at my fingers here. The wave is moving this way. This way and this way. There's a line there, and the Kleenex is moving that same direction. Let me. Since your fingers seem to be talking.
These were dysfunctional.
All right. Would you all agree that this is the direction that the wave is moving?
Yes.
Okay. And the direction that the Kleenex is moving?
Yes.
Yes.
So how do you describe those two directions?
Parallel.
Parallel, okay? Keep that in mind. All right, hold it for a second, y'all. Over here to this. Keep it on the ground this time. Give me a transverse wave. Nope, totally on the ground. We'll go back and forth like this. Wait, there you go. All right.
Oh, it's moving.
Give me one specific wave. Give me one impulse. There we go. Go again. All right, from Kevin, what is the direction of the wave? Point with your fingers. With his,
This way, you mean.
it should be going this way. We should be able to see it travel. Can y'all see it travel?
Yeah.
I'm not a cowboy.
Okay, it's going. We should be able to see it going that way. You're really good in there. Maybe with the carpet. I don't know. All right. So would y'all agree that this represents the direction of the travel? It's going this way. If this was tight enough, we'd be able to see it hit Gracie's foot and bounce back. Okay. Now, what is the direction of travel of the Kleenex?
Perpendicular.
Perpendicular. Do you see the difference? Okay. So this Kleenex is moving up and down perpendicular to the travel of the direction that the wave is traveling. This is what's called a longitudinal wave. Now, that was great when you're going side to side. Go up and down.
Oh.
Okay. What's the direction of the waves? Still that way. Okay. What's the direction of the Kleenex? Up and down.
Wait, but this is a trans-studial wave, isn't it? And you just said it was a long wave.
This is transverse wave.
Oh, there you go, transverse.
This is transverse. Transverse means that the path, the direction of the wave is perpendicular to the motion of the particles. This over here, longitudinal wave, the direction of the wave is parallel to the direction of the particles.
Okay, that makes sense.
Okay.
Just LL.
Long- longitudinal, like long waves, and transverse, perpendicular. Trans makes it T. There you go.
And parallel, how does that work?
Parallel, longitudinal. Okay. Now, it was interesting to note. Okay, so it's pretty obvious. This one's going back and forth. The tissue is not moving down the line, right? The rope itself is not moving down. Okay. The medium doesn't like move. Okay. The medium, I mean, it does move, but it doesn't like displace. Okay. Individual points will displace back and forth and stuff like that and pull each other up, but they're going to pull each other back down. Consider over here, even this one, give us a longitudinal wave there. Emily? This point did move a little bit in the direction, but then it kind of moved back. Did you see that? Okay. Now, some interesting things that we will discover is that sound is a wave, and it's a longitudinal wave. What happens is when I say hello, I'm causing the air molecules in my throat to bump into other molecules. Just like when she gives that a push, it causes the slinky to bunch into the other slinky parts, okay? And then that causes the air molecules in my mouth to bump into the other air molecules, which causes them to bump into the other air molecules. And so it's sort of like there's a little mini explosion going on here, and then out of my mouth it goes off in that direction, and bump, 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 bump. So the air molecules, they get compressed, and then they kind of spread out a little bit, and it's going off in all directions, and it goes into your ears, and 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 then you're gonna, oh, now you've got to go mess with me. What sort of a wave is that? What kind of wave are we looking at here, class? It's a transverse wave. Now, they're doing something special. They're kind of making it look like it's almost like standing still. That's called a standing wave, and that's chapter 16, so you can't do that just quite yet. But it is kind of, because you don't know what that is. Yeah, there's standing waves. This is a standing wave of mode 2. Go ahead and do it. Well, you did have it in mode 2.
They were going in the same
There you go. Where it's kind of like this one's almost stationary, and you kind of see these guys going back and forth. Yeah, this is the node and anti-node. There's kind of all sorts of stuff. And then you can have different modes of nodes. We'll talk about all that.
I kept saying
Modes and nodes. Oh, there you go. There's mode 3. Okay. Oh, adding energy. And by the way, those are different resonant modes. You know, if you remember last chapter we talked about resonances. We'll talk more about that in the future. So let's go back here to the rope, and actually we're going to switch it up here. Emily and Miranda, go ahead and grab those super long slinky.
it makes so much
The
noise.
super long, I guess it's not a slinky, it's a spring. Just line it up here next to these two. And Ivan and Emily line it up as well. You can put on the ground. We're going to make,
Put on the ground?
yeah, put on the ground. We're going to try to make,
You said for me.
okay. Miranda, can you send a longitudinal wave? Oh, it kind of died off.
There you
Here, tell you
go.
what.
It went back, yeah.
Here's what you do. Hold it with one hand. Grab a chunk of it right up here and pull it really close to you. Keep pulling. All right, now let it go. Oh, there's a little bit of transverse action there too. Try that, or you can think of another fun thing. You can stretch it. Oh.
I felt that.
All right, send her a transverse wave. Put it. Try to put it right there on the ground. Put it right there on the ground. So that way, it's almost all.
A transversal wave?
Yeah, no, not a transverse.
Oh.
Send a longitudinal wave.
Did you feel it?
Yeah. Okay. Yeah. Ooh, great.
We can do the most small.
Yeah, maybe a longitudinal. Can you make a longitudinal wave there with that rope?
We tried to pull like a
Yeah.
Why is this so funny?
Kind of sending the signal there. It's fast, isn't it? Okay.
Yeah.
All right, we're gonna have a
Wait,
race.
so the harder the spring constant is, the faster it goes?
Ooh, yes. Great point. Y'all hear that? Say that again, Miranda.
The harder the spring constant is, the faster the wave goes.
Yeah. The harder the spring constant, the faster it's gonna go, because remember, a high spring constant means it's gonna be really tight. And so if it's really tight, then it's gonna send that information off really fast. James, you're doing awesome. You can also kind of get behind them, behind their backs, and kind of get all three of them at once. So let's have a longitudinal race here. Ivan versus
We're gonna win.
Emily here. Ready? 1, 2, 3. All right, hold on. Ready? Ivan and Emily. When I drop it, I want they're gonna do it. Okay? Ready? Set. Release.
They won.
Yeah, I think y'all won. Okay, so what makes it, generally speaking, okay, ready? Let's go, Ivan versus Kevin.
1, 2, 3.
Oh, I think I saw something. Did you see that? Go ahead. Ivan versus Kevin. Ready? 1, 2, 3.
Oh, yeah.
Ooh.
You can see it.
Yeah, so broadly speaking, because here we have rope versus slinky, what makes the difference in how fast the wave travels? How tight it is, the tension, okay? And what I'm going for initially is the properties of the medium, okay? So the properties of the slinky or the properties of the rope or the properties of the spring, that's what's going to make a difference with how fast it goes. Does that make sense?
Yes.
Okay. Let's see what else we can do. Crossover tie in here with pre-cal. Kevin, give us a sine wave. Okay. Maybe go back and forth. Go x, y. There. Right, no z. So he's given x, y. Now, do y'all see it's diminishing? Yeah, all three of us. Give us an x, y right there. Okay.
I'll let you do it. Yeah, I know.
The other is that better?
Yes.
Please. Having fun?
Yep. Okay. Now, ladies, y'all need to stop for a second.
Oh.
This screw, I want y'all just to send it down here to that side. Send it, y'all just send it down. I want to see what happens
I'm
to
not
this.
all the way through this.
Why is it dying over there with the string? Why do y'all think?
Because of friction in the thing.
Yeah, we got friction.
And it was long, like, it was too long.
It does come back a little bit. We'll talk about reflections in this chapter as well.
Oh, it's been there until we got all the way to mine.
Yeah.
Oh, it comes back. All right, increase the amplitude there, Emily. Ooh, there we go. Well, one thing that we'll try to find out is that it'll, yeah, it actually,
It goes back.
it comes back, yeah, it reflects. But when it comes back, it's inverted.
Oh, you're right.
Watch, up there,
Oh,
down there. Now it's kind of hard because this spring is actually kind of hanging out up here. But you'll notice
you can
that
tell
the
with this
wave
one.
that comes back is beneath. Go ahead, try it in there, Emily.
You could tell with Ivan's.
Yeah. I can tell with yours.
With Ivan's.
Ivan's, okay.
Yeah.
All right, Emily, give it a above and below. Above and below. Do y'all see that?
That's cool.
Yeah, it's pretty. That's one of the properties of, no offense, Ivan, a hard boundary. When a wave comes up and hits a hard boundary, it inverts and goes back. Where it was positive, it becomes negative. Okay? All right. I want Vinjay and Belle to get some chance here. Why don't y'all try with the rope since Ivan and, Kevin and Gracie have had that rope for a while. See if you
Ooh,
get some
I don't like
chance.
that.
I know, I heard.
Y'all want to switch? Take this. Y'all switch with Ivan
Okay.
and Emily.
Young scallywags. You're a scallywag.
It looks like a snake.
Yeah.
It does.
Creepy. Sorry. Thank you, Sir Goddard.
No problem.
It feels so weird. Oh, wait. Let's move one of the pushes.
Record for a second. Your hands hurt?
All right.
Am I supposed to do it back?
You can if you want to. If you want to play catch, that's fine. So, like I said, one of the most important things is that you understand that a wave is a disturbance in the medium. Y'all see how it's disturbing it? The medium, the spring, the slinky, the rope, is not necessarily all moving along with it. It's just the spring, the string, the rope is it's sort of like the messenger. Does that make sense? See?
I like this playing catch instead of the.
Belle is sending a message to Vinjay via the rope, and Vinjay's sending a message back. The rope is really not moving. It's just like a conduit of that disturbance. All right, go ahead and let's change one more time. Miranda, y'all go ahead and get the rope, and Emily get the rope. James, get in on here. Gracie, go ahead and grab. Let's see. I don't know. I want James to get in here. James, you take Ivan's place. He's been there for a while. Well, I guess you're still stuck on the screen. And we'll have fun out here again when we talk about standing waves.
I'm really bad at the
Now
video.
that's pretty noisy. See, look, you keeps flopping up and down. See that? It's not like that tissue is not moving at all.
I'm trying so hard.
I know.
Oh,
Just grab
I'm
a-
getting it to you.
Grab a real big section. Grab it like a foot.
Hold,
There you
hold
go.
it,
Yeah.
hold it tighter, Emily. That'd be easier.
There you go.
No, you
Oh, just give it a good push.
Fell
Give it a
next
good
time,
push.
off.
jump it.
Oh.
Hand eye coordination. Foot eye coordination.
I'm gonna.
Yeah, it's you're going against gravity that way. At least if you're going on the floor, you're going against friction. There we go. They got a standing wave. Y'all are way ahead of the game here. Oh, nobody look like they're having fun. Very good physics.
That's
Awesome
first.
physics. Look at that, man. Y'all get this awesome standing wave. Remember how I said there's a natural frequency that things like to go at?
Senor Ivan.
Yeah, they also they like to. Well, this is actually not the natural frequency. This is 3 times the natural frequency.
Okay, natural will be the whole thing going in.
Yeah, give us the natural frequency. Back and forth. There you go. That's the natural frequency.
Am I supposed to go in time with him?
Yeah,
Yeah.
yeah. That's the natural frequency. We call that mode 1. Now go twice that. Go twice that fast.
So opposite each other.
Oh, and then when you go 3 times, that's when it has the 3.
Yeah. With so that's I'm really jumping ahead of the game here, but that natural frequency is called the fundamental in music, and then double it is your higher harmonic. If you're in with that, in tune with that world. All right, and we got standing mode 3. With that spring, you might be able to get higher modes too.
Y'all should like back up. Yeah.
Yeah, I'm on a skip. They're coming for y'all.
All right, watch out. Here we go. Go faster, faster.
So James, go that way a little bit.
Not more amplitude, higher frequency. We still just have 3 nodes.
Is it possible to get 4?
All right, bring it in. All right. Let it go.
I'm against the wall.
All right. Inside, let's go class.
On the road again.
She left.
I got that.
Thank you though.
Just can't wait to get on the road again.
I was gonna see if I could make Kevin trip, but I couldn't. Because you kept walking.
Stop
You're doing
being so close.
I gotta walk somewhere, woman. Sprinky. Senor Sprinky.
We can try this later on. It's the Edibot. We might be able to do a customizer where you write your
How do you do this, Ivan?
monogram.
Yeah.
So it's supposedly you can draw on an egg or a ping pong ball, but I think also golf balls. So,
You're strong. You can take it away from me.
Pathfinders.
Huh?
All you, Ivan.
Okay, fair. You know what I'm about?
That thing is
I was asking that. No,
It's the other way around. No. I mean, the other way around.
all right.
Oh, like this.
Yeah.
Y'all have notes, right? We're gonna add on the notes. We're gonna do some side and in to the side.
Oh.
You can do these things.
No, that's kind of.